Our second lesson of this unit is going to be learning how to use properties of logarithms. So these are very similar to our properties of exponents. So let's start off with inverse functions. So we know that two inverses are going to cancel each other out. And so whenever we have an exponential and a log with the same base, they're also going to cancel each other out. So in this case, b to the power of log base b cancel each other out to just leave you with m. Same thing for our second property. When we have log base b of b to the power of m, again they just cancel out to give you m. We have three other properties that come from our laws of exponents. So just like with our exponents, when we have log of something that's being multiplied, we can separate this into two separate logs that are being added together. So when it's being multiplied, we can separate them into two separate logs that are being added. So with our division, if we're taking log of something that's being divided, we can again separate them, but now instead of being added, they're being subtracted. And finally, we do have a new property here, where if you have an exponent, we can actually bring that out in front of the log, so that this is equal to k, whatever your exponent is, log base b of m. So we can move the exponent from inside the log to out in front of the log. So let's take a look at some examples using these properties. So for number one, we're trying to evaluate this. So this is kind of what we did yesterday, but this is actually going to be even simpler. So we have 5 to the power of log base 5. So since they're both the same base and they're inverses, this cancels out to just give us 18. Number two, very similar, we have log base 3 to the power of. So again, same base, they're inverses, they cancel out, it just leaves you with x minus 2. For number 3, we know that ln, whenever we see ln, this is base e, and so again, this log base e and e, they're inverses, so they cancel each other out, and this leaves you with 3t. Let's go on to the next section. So we're not going to be putting together a whole bunch of these to evaluate each expression. So number 4, again, log base 5. They cancel each other out, we're just left with root 3. That's a really simple one. Number 5 gets a little bit trickier. So before we can cancel out our 4 and log base 4, we first need to put together this section. So see how we have a 2 here in front of the log? Because it's in front, we can actually combine it and turn this into an exponent. So we know that if it's out in front, we can turn it into an exponent. Alright, so this is 3 squared now. Since these two are being added together, we can combine them into one log. And if they're being added, this is our property number 3. So if they're being added, when we combine it into 1, they're not going to be multiplied. So this is now 6 times 3 squared, and 3 squared is 9. Right, so this is 4 to the power of log base 4. 6 times 9 is 54. And now that it's all one log, now we can cancel out our 4 and our log to give us, this is just 54. So first we need to make sure this is all one term before we can cancel it out. Okay, so for number 6 and 7. So this one we're trying to express as a single logarithm or rational number. So we're trying to put it all together to just be 1. So we're trying to, really what we're trying to do is condense. We're trying to put everything together. So for number 6, we're trying to put everything together. First, let's look at this 1/3. This 1/3, because it's out in front, we can actually turn this into an exponent. Right? We also have, if we're trying to combine these two, this is a subtraction. So if we're turning it into one single log, subtraction becomes, we're looking at our rule number 4, division. So this is log base 2. We're going to keep the same base, so the bases never change here. This is 48 over 27 to the 1/3. Right, because subtraction becomes division. Now 27 to the 1/3 we can actually find, because 27 to the 1/3, this 1/3 is the same thing as root 27. And root 27 is just equal to, so what to the, or cube root of 27. Cube root of 27, what to the 3rd power using 27 is 3. So really this is log base 2 of 48 divided by 3. We can actually divide 48 by 3. So 3 goes into 4 one time. We're left with 18. 18 divided by 3 gives you 6. So 16. So 48 divided by 3 is 16. So now we're trying to find log base 2 of 16. And this is something we just did yesterday. So we know our base is 2. Our answer is 16. So we're looking for 16 equals 2 to the x power. So 2 to what power gives you 16? If you look at your little chart, you know that's going to be 2 to the 4th power. So log base 2 of 16 is equal to 4. So that's my final answer for this problem. Okay, let's look at number 7 now. So again, we're condensing, so we're trying to put everything together. So let's start off by what's inside of the parentheses. So we're trying to combine all of these. So we have log base b. When we have m and n that are being added together, we know that those are going to be multiplied. But a subtraction means that we're going to divide. Right, so the way we're going to write this is if we have m times n, I'm just going to write them together, divided by p, it's going to look like this. So now I've turned them all into one log. With this 1/2, what I'm going to do with this 1/2 is put it up as my exponent. So this is log base b of mn over p to the 1/2. And I can actually rewrite this 1/2 as square root of mn over p. So this is my final answer. Since they're variables, I can't actually evaluate them. That is this as a single logarithm. So for number 8 and 9, now we're expanding. So now we're taking it and we're trying to go the opposite direction. So we're starting off with something that's 1 log and separating it. So let's start off with number 8. So for number 8, we just have log of 18. What I first need to do is split 18 up using a factor tree. So 18 is 2 times 9. Right. And 2 is a prime number, so 9 I can turn into 3 and 3. So log of 18 is the same thing as log of 2 times 3 times 3, which I can also rewrite as log of 2 times 3 squared. So if we're trying to separate them, this times, if I turn it into 2 logs, this is going to be log of 2. Multiplication turns into addition, so plus log of 3 squared. And this exponent, I can bring this out in front. Right, so this is now log of 2 plus 2 log of 3. And for this one, so I know this is a base of 10, right? So 10 to what power is going to give me 2? And this isn't something I can solve, so I can't simplify that anymore. Same thing over here, 10 to what power gives me 3? I also can't solve that one, right? So this is going to be my final simplified form. Okay, let's look at number 9. So ln, so we're just going to keep it as ln. So ln of, first of all, this x is being multiplied by that root 1 plus x squared. So I'm going to separate it using addition. And I know that this square root is the same thing as ln of 1 plus x squared to the 1/2. And so since 1/2 is my exponent, I could take this and bring it out in front. So ln of x plus 1/2, ln of 1 plus x squared. And now I actually cannot do anything else. So ln of x and ln of 1 plus x squared, I can't simplify any farther. So this is my final answer. So note, I even put a little note here. Log of n plus n can't be rewritten using the property of log. So if they're both inside of this, I can't separate this anymore, because for you to separate one term, they would have to be multiplied or divided. That's my final answer.